climate change scientists measuring global warming projections last year began to detect much higher projected temperatures than previously found. The readings point to much hotter temperatures, with estimates at around 5 degrees Celsius by the year 21,000. Climate scientists had previously advised that if we kept global temperatures below 1.5 degrees Celsius, we could stave off disastrous weather conditions like flooded cities and devastating droughts. But the latest readings have triggered fears of severe climate conditions sooner than expected. But just how bad will it get, and how much time do we have? Well, to help us through some of these complex questions, we're joined now by climate change justice activist Professor Vishwas Satgar from the University of Witwatersrand. Prof, thanks for your time. Welcome to Newsroom Africa.
Good morning, and thank you for having me.
Before we talk doom and gloom and Armageddon and everything associated with it, and I don't mean to be callous about the situation, let's first understand how it is we got here. You know, a lot of skeptics pushing back against the idea of global warming are saying, but this not only has happened before, but was somewhat inevitable. I mean, where are we insofar as that kind of back and forth is concerned?
So we have very, very credible climate science in the world. And before I get into it, let me just put a disclaimer forward. I'm a political scientist, so I study the political implications of climate science and the politics of climate change. So I have to look in this direction. Now, we have very, very good climate science. We've had climate models in existence at least for half a century. And since the 70s, those models have increasingly been giving us relatively accurate data. These models actually put together a whole set of variables. They look at energy flows, they look at water movements, clouds, etc., etc. This approach has impacted the creation of the International Panel on Climate Change in the late 80s, and particularly announcements by leading scientists from the Goddard Institute linked to NASA, James Hansen. These voices all gave it a spur, to the point where when we entered the 90s, we saw the creation of the multilateral framework to negotiate and to deal with this big problem. The science was driving that process.
Right.
Today, we actually have even more sophisticated climate modeling. The UN is going into what is called a 6th cycle of reporting. By next year, another set of, if you like, data will come to the fore. Now, these models have been getting better. They've been using all kinds of new metadata, etc. And they're giving us more accurate readings. So, in a sense, you know, the skeptic's position, the denialist position, stands against an over 97% consensus of the top climate scientists in the world. So here you're talking about modelers sitting in the Met Office in the UK, the top research universities in the US. You're talking about China's climatologists, the top ones, also doing this kind of modeling, etc. So in a sense, here you have very efficacious, very clear, coherent science that's speaking to this challenge. Now, the whole issue around whether we are going to see greater heating has been an old question. In climate science in the late 19th century, a Swedish climatologist, pathbreaking Arrhenius, was grappling with this question. If we double greenhouse gases concentration on planet Earth, what are the implications? What is Earth's sensitivity, or how hot will Earth get? Now, this has been an issue for climate scientists since the late 19th century. This has informed how the IPCC, and particularly the multilateral UN framework, has been thinking about things. The consensus, at least for the past few decades, was that if we double the concentration of greenhouse gases on planet Earth, we will probably see a 3-degree increase in planetary temperature since the Industrial Revolution. Now, the current models, the cutting-edge models, are crunching the variables and looking at the planetary climate system, and they are coming out with a different number, which is closer to 4 degrees. Some of them are even showing an overshoot of 5 degrees, and so on and so on. Which means that the Earth, with more emissions, more extraction, more use of fossil fuels, and so on, is heating up to a dangerous point.
Right.
It has implications for how the UN has thought about scenarios of climate heating, which is what has been, if you like, negotiated. It's formed the basis of risk perceptions. It's formed the basis of policy making in national states around climate adaptation, mitigation, and so on. So this is a very, very serious issue.
Sure. I still get a sense, though, that the point of contention is not necessarily around whether or not the planet is heating up. It's around whether or not humans are single-handedly responsible for that. And if the answer to that is no, then perhaps the messaging around the very visible changes we're seeing to our climate needs to change. I mean, are we sort of being able to communicate effectively why we're here and the contributions that humans are making to that reality?
So climate science, again, is very clear on this question. So for the past 150 years, we've used coal, then oil, then gas. And that has contributed to, if you like, an extreme concentration of carbon in the planetary atmosphere. The science is very, very clear on this. In the middle of the century, 1950, you saw a golden spike. The Keeling curve from the 60s.
What is a golden spike?
Meaning more use of carbon and so on, right? The Keeling curve from the 60s was also beginning to count the amount of concentration, okay? And it was increasingly going up and going up. And basically what we've seen, at least over the past 3 decades, is an explosion of fossil fuel use and carbon extraction and things like that. So the consensus in the science is very clear that the way we live, the industrial societies we have, the way we engage in industrial agriculture, etc., the cement industry and so on, all carbon-based, have contributed to this problem. Now, the big issue is how do we tackle this problem, okay? Because it does require us to engage in massive restructuring of our societies, to decarbonize our societies. And where we are sitting right now, we've lost almost 20 years to tackle this problem. Because if you look at the multilateral negotiations, since the attempt to put in place what was called the Kyoto Protocol,
yes,
based on the principle of common and differentiated responsibilities and so on, most US, actually all US presidents, refused to really lock in. The United States is responsible for the highest concentration of historical emissions on planet Earth, okay? It has had the highest per capita emissions.
How far are they from China?
China right now is comparable to the EU at a per capita level. It's actually edged upwards, okay? Right. China's aggregate also now is at the highest point. And there's a lot of contention about this data and how you look at it and so on, but it's recent, over the past 20 years. For the US, it's been a long time. So the politics has, if you like, been scuppered by the United States. Most US presidents don't want to negotiate the American way of life around this issue. China right now, it's interesting to look in that direction because China has, if you like, attempting a mixed energy, if you like, economy. It has some of the biggest push towards renewables, while at the same time it is still a coal-heavy economy.
All right.
Okay?
We're going to have to leave it there, sadly, especially because, there's still so much to speak about, especially if we sort of get into the area of political will, which is,
yes,
the sense I was getting you were going to. All the more reason for you to come back. So
thank you.
Thank you very much for coming
having
through
me.
For this run of the discussion. Professor Vishwas Satgar is, of course, an associate professor at the University of Witwatersrand and a climate change activist himself. Thank you once again.
Thank you.